Section 11.1, Angle Measures and Polygons. By the end of this lesson, you should be able to find interior and exterior angle measures of polygons. We learned before that the sum of all the interior angles of a triangle is 180 degrees. We also learned that the sum of the interior angles for a quadrilateral is 360 degrees. And when we were talking about that, we talked about how you could come up with this by dividing your quadrilateral into two smaller triangles. And then from that, we'd be able to see that the sum of these angles would be 180 degrees. The sum of these angles is also 180 degrees, where we could say 2 times 180, or the two triangles that we were able to form, is going to be equal to 360 degrees. So we're going to take a look at a couple other polygons and come up with a general formula that we can use for any polygon. We're going to take a look at pentagons first. And the first thing we want to do is write down the number of sides. We are able to see that there's 5 sides for a pentagon. And next we're going to take a look at how many triangles we can end up forming from it. So drawing in these lines, we can find that we have 3 separate triangles that we can form inside of a pentagon by drawing diagonals in. And each of these triangles is going to have a sum of 180 degrees, which means the total sum is going to be 540. So the number of triangles we were able to form was 3, and the sum was 540 degrees. A hexagon has 6 sides, and we're able to form 4 triangles in this hexagon. So if we wanted to find out the sum of the interior angles, we would take 180 plus 180 plus 180 plus 180, or 4 times 180, and find that the sum is going to be 720 degrees. Heptagons have 7 sides. And if we draw on the diagonals in order to make triangles, we'll find that we're able to make 5 different triangles. Which means then we can say that 5 times 180 degrees would give us the total sum of the interior angles of a heptagon. So looking at this, we can tell that if we had 5 sides, you're able to come up with 3 triangles. 6 sides, you're able to come up with 4 triangles. 7 sides, you have 5 triangles. So in general, it seems like however many sides you have minus 2 is the number of triangles you're able to come up with. Then we also know that every single triangle is going to have a sum of 180 degrees. So we can multiply that by 180 degrees to get the sum of the interior angles of a polygon. And then we can use this with any type of polygon, whether it's a hexagon or whether it's a 100-sided polygon. So taking a look at what we just said, we can say that the sum of the measures of the interior angles of a convex polygon is n minus 2 times 180, where n represents the number of sides. The measure of one interior angle of a regular convex polygon would be the sum, so these two formulas are exactly the same, but then I'm going to divide it by the number of sides it has. Let's try some practice. So here we're asked to find the value of x. In order to find the value of x, I need to figure out what the sum is for all these interior angles. So first we need to figure out the sum of the interior angles of the polygon, and to do that we're going to use our formula. So our formula is n minus 2 times 180 degrees. So the number of sides I have here, I have 1, 2, 3, 4, 5 sides. So 5 minus 2 times 180 degrees, which would be 3 times 180 degrees, will equal 540 degrees. Now that I know the sum of the interior angles, I can use this to set up an equation. So we can say that x plus 120 plus 90 plus 151 plus 56 is going to all add up to 540 degrees. So simplifying, we're going to get that x plus 417 degrees will be equal to 540. And then when we subtract 417 from each side, we get that x is equal to 123 degrees. We also had some theorems regarding the exterior angles of polygons. And the sum of the exterior angles of a polygon will always add up to 360 degrees. And this is the case, you can see, and we'll see some sketchpad activities tomorrow, how all of these will condense on themselves to form all the degrees of a circle. So we can say the measurement of angle 1 plus 2 plus 3 plus 4 plus 5 will all add up to 360 degrees. If you have a regular polygon, so let's say we have a regular pentagon here, all of the exterior angles that we're able to have here will all be congruent to one another. So if I'm interested in finding one of the exterior angles of a regular polygon, we are just going to need to take 360 and divide it by the number of sides that you have. Let's try some practice. So here, instead of having to calculate the sum of the exterior angles, we already know that all of these are going to add up to 360 degrees. So we can say 2x minus 12 plus, this one's 90 if this one is 90 degrees because they have to be supplementary since they're a linear pair. So plus 90 plus x plus 2x plus 32 is equal to 360 degrees. So combining like terms, we have a 2x, x, another 2x. We'll find that we have 5x plus negative 12 plus 90 plus 32 makes 110. This is all equal to 360 degrees. We'll subtract the 110 from both sides, and we're left with 5x is equal to 250 degrees. And dividing by 5, we get that x is equal to 50. For the next one, we're interested in trying to find out what one exterior angle of this polygon is. Now we know that this is a regular polygon because it's equilateral and it's equiangular. And if it's both equilateral and equiangular, we can say that it's regular. So for this one, we just merely need to count up the number of sides that we have, and we can say that our x is going to be equal to 360 divided by whatever number of sides we have. And here we have 1, 2, 3, 4, 5, 6 sides. So x will be equal to 360 divided by 6, which is 60. So x is equal to 60 for the second problem. That's really it, but these are formulas that you're going to need to make sure you understand and can recognize the different properties when you see them so that you can apply them. And that's all for right now, so it's time for our joke. And our joke is, what do you call an alligator in a vest? Well, you call him an investigator.